All right, friends, let's see what we have here. As I keep saying, feel free to follow along, pause the video whenever you need. Make sure you are thinking ahead of me, because the more thinking you do, the better. And let's see, so we're given a curve, y squared is 2 plus xy. That's all we're given for this time of the question. There's nothing more. So what I'm going to guess we're going to be asked to find the derivative. So to find the slope, we might be asked to write a tangent line. We're going to have to use implicit, I'm going to write it down because it's a fancy word, implicit differentiation. So the question is set up like that, so I bet that's going to come into play. Let's see what we get. Boom, first question, implicit differentiation. So let's do it. The derivative of y squared is 2y. And don't forget chain rule. Since we're taking the derivative with respect to x, we have a dy dx there. The derivative of 2 is 0. That is a very common mistake right there, is to leave the 2 there, so be super careful. And then an xy is a product. If you need to write it like this so you see the product, feel free. The derivative of x is 1, and then we multiply by y. If you want to put the 1, you can. It's not going to hurt you. And then x, and then the derivative of y, keep in mind it's with respect to x. Let's go ahead and do some algebra. I'm going to collect all the dy dx stuff on one side. Subtract x dy dx, and that is equal to y. And then I'm going to undistribute, also known as factor, out the dy dx. 2y minus x equals y. And then I'm going to divide. Dy dx is y over 2y minus x. So the key for taking derivatives when you're looking at these implicitly defined functions is to remember this dy dx. It's all about remembering what your derivative is with respect to. If your derivative is with respect to x, then you got to have the dx stuff there. If it's the derivative is with respect to t, you got to have the t stuff there. And what do we have here? Find all points where the line tangent to the curve has a slope of 1/2. I forgot how to talk there. I'm sorry. So we just have to remember what our dy dx was. So our dy dx was y over 2y minus x. And we want to know, when does that equal 1/2? And let's go ahead and do some algebra. So we're going to have y, I'll write it as 2y, multiply both sides by 2, and multiply both sides by 2y minus x. So that is when x is 0. So that's one place that will work. And so when x is 0. And we got to go back to the original function with that x is 0 piece. So we have y squared equals 2 plus 0 times y. So that means that y squared equals 2, which means y is the square root of 2. Oh, don't forget the plus or minus. I bet some of you will forget that. So you need to have 0 and the square root of 2, and then 0 and negative square root of 2. And that's it. And let's look what we have here. Show that no points in the curve where the tangent line is horizontal. So let's remember, the derivative is 2y minus y over 2y minus x. We want to know, when does that equal 0? Happens when y equals 0. If y equals 0, then 0 squared equals 2 plus x times 0. 0 equals 2. Since 0 does not equal 2, there are no points on the curve where the tangent line is horizontal. We did that part. Okay. Last piece. x and y be functions of t. Okay, we're going to have to do some different kind of differentiation. At t equals 5, the value of y is 3, dy dt is 6. Find the value of dx dt when t is 5. So, if y... Well, I'll come to that. I might need to find x, and I can do that. Yeah, I'll show you how to do that. But let's go ahead and take the derivative. So now we have to take the derivative with respect to t. So we're going to have a 2y dy dt. That's a dx. dy dt equals, once again, the derivative of 2 is 0. And don't forget product rule. So the derivative of x with respect to t this time plus x dy dt. Now I need to know what x is. So I was going to find that, but let's go ahead and do that. If y equals 3, then 9 equals 2 plus 3x, which means x equals 9 minus 2 is 7 divided by 3. And now we just need to plug things in. So we can go ahead and plug in 3 for y, 6 for dy dt. We don't know dx dt. That is our unknown. 3 for y. T we just found was 7/3. And dy dt is 6. So let's go ahead. 2 times... Oh, I could do that. No, that makes it scary. 2 times 3 is 6 times 6 is 36. 3 dx dt. I was going to cross out a 3 from everyone, but I didn't want to scare you. 7/3 times 6, so that's like 2, so 14. Subtract 14 from both sides, and I will get 22 equals 3 dx dt. So then dx dt, now we're only looking at when t equals 3, is 22/3. Let's see how we did. So we have the whole question. The stem, the only information in the stem is this function, y squared equals 2 plus xy. That is an implicitly defined function. If you see that, chances are you're going to have to find the derivative. So you're going to have to find the derivative implicitly, which means don't forget about dy dx showing up. So that was the first part. They asked us to find that derivative. Then we had to use that derivative in parts b and c to figure out places where the slope was either 1/2 or 0. The 1/2, you just had to find the x value, and then use that x value to find the y value. For part c, we had to show that we could not do that. So the key there is you need the slope to be 0. The only way for the slope to be 0 is if y is 0, and that can never happen. And then for part d, you need that taking the derivative with respect to t. Let's see how we did. We showed that part. I used dy dx instead of y prime, but you can definitely use y prime. We showed that for b, and don't forget the plus and minus, very important. Y and then 2y minus x. I have some students, just as an aside, that would definitely try to cross those out. Don't do that because that's illegal. And so we get y is 0, plug that in, doesn't work. So we already checked that. When y was 3, so they found what x was right away. I found that second. Then you find the derivative. Okay, so they found the derivative this way. They used a kind of chain rule piece there. Totally fine. Where they said dy dt is dy dx times dx dt. So dy, if you think of that, dy dx times dx dt. If you think of this as fractions, they're not, but think of them as fractions. You can cancel kind of like that. Gives you dy dt, and that would be okay. And that's all you need to do there. I did that differently. I took the derivative directly from the function, which is totally fine too. Either way is great. We got 22/3.